So in the last module, we have seen some different types of sensing technologies. So now let us see what is this inductive loop detection. So basically this loop detection is buried into the pavement at the intersection, as we can see in the rectangular shapes. So this is how the inductive loop detection is there, which is being buried into the pavement surface. So as soon as a vehicle cross by, it sense it and give some sort of information. So this inductive loops is placed in the roadbed to detect the vehicles as they can pass through the loop magnetic field. So this is a magnetic field over which the vehicles is passing by and it is capturing the information. So basically, the simplest detectors can simply count the number of vehicles during a unit of day. So that passes over the loop, which is generally sophisticated sensors to estimate the speed, length, and classes of vehicle which is passing over them. So this loops is basically placed in a single lane or a multiple lane, and they can work very slow. They work with very slow or stopped vehicles as well as vehicle which is moving at high speed. So this is the inductive loop, which is rectangular in shape. So either we can provide in a single lane or in the multiple lanes, where this magnetic field will try to get the information of the vehicle like pertaining to speed, the vehicular volume. So that is how we can collect the data which is for the vehicles which is moving onto the road. Like we can collect the different types of vehicles, that is the volume data can be recorded by this inductive loop detection. So this is how it looks like. So this is again an example of inductive loop detection. Next, coming to video vehicle detection. Now how can we detect the video of the vehicles? So basically we are able to place video cameras which is non-intrusive. So the inductive or the intrusive is nothing but we are able to bury different type of parameters or the things onto the pavement layer. But in this non-inductive method, which is nothing but vehicle detection, wherein which we are able to place the different types of sensors away from the pavement surface, like it is there near to the surface of the road, where some cameras or CCTV cameras are being placed nearby the buildings or some vantage point, so in order to collect the data. So let us see what is this non-intrusive, which is video vehicle data collection. So the traffic flow measurement and automatic incident detection using the video camera is another form of vehicle detection. So in this we are using the automatic number plate recognition, which by installing any component directly onto the road surface or road bed. So basically what we are doing is we are able to install any components which is not directly on the surface of the road but somewhere away from the road, such that it is called as non-intrusive method or the traffic data collection for the traffic detection. So basically here what we are doing is the video cameras is basically fed into the processor, which analyzes the changing characteristics of the vehicle image that pass by. So basically the cameras are mounted on the poles or structures or adjacent to the roadway. So the adjacent to the roadway we are able to place a camera. So a single vehicle video detection processor can detect the traffic simultaneously from 1 to 8 cameras, so depending on the brand and the model. So basically this video data processor can detect 1 to 8 cameras as well. So we are getting huge amount of data if we can place this to the above or adjacent to the roadway. So this typical type of video data collection is lane by lane with we are able to get lane by lane the vehicle speed, count, and lane occupancy readings. So here we are able to find out what is the gap between the vehicle, what is the headway, what is the stopped vehicle direction, whether any wrong way driving is happening or not. If so it is happening, we can also give different types of alarms based on this vehicle video detection, which is non-intrusive. So one was intrusive, where we are placing the different type of sensors on the road. So this is an example of inductive intrusive, where we are able to place some sort of sensors onto the road, which is buried just beneath the surface of the road. And this is non-intrusive, where we are seeing that we are able to place the CCTV cameras or some sort of video data collection parameters, such that it is able to monitor the traffic onto the road. So this is how the video data detection look like. So these are different examples of the video vehicle detection. Now coming to another detection, which is a Bluetooth detection. So what is this Bluetooth detection? So it is an accurate and inexpensive way to measure the travel time and make the origin and destination analysis. So we are able to measure the travel time, okay, between the two vehicles, and we are able to find out the origin as well as destination. So we can do OD analysis from where the vehicle has been starting and where the vehicle is been reaching the destination. So it is basically a wireless standard which is able to communicate between the electronic devices like the mobile phones, smartphones, headset, navigation system, computers, etc. So as like different parameters, just told, like a smartphone, okay, mobile phone or headset or navigation system, it is a wireless standard which is used to communicate between the electronic devices. So this Bluetooth is being installed in these parameters where we are able to communicate on to the road. So this Bluetooth road sensors are able to detect the Bluetooth MAC address. So we are able to see or detect or to determine the MAC address from the Bluetooth devices which is passing the for the passing by vehicles. So if the sensors are interconnected, they are able to calculate the travel time and provide the data for OD matrices. So we are able to find out what is the travel time reached from one vehicle from a point A to point B, and then we can able to find out the data for OND matrices. So compared to other traffic management technologies, so Bluetooth have some sort of differences. Some sort of differences are there when we compare to different technologies like intrinsic or non-intrinsic. So accurate measurement points with absolute configuration to provide the second travel time. So it is basically a non-intrusive. So non-intrusive in the sense it is not buried just beneath the surface of the road, but it is there on the road, okay. So which leads to lower cost installation for both permanent and temporary site. So it is limited to how Bluetooth devices are broadcasting in the vehicles. So counting and other applications are limited. So basically, so if the Bluetooth devices are on, then only the broadcasting system or the counting of the vehicles can be applied, and hence its application is bit limited. So basically it is a quick startup with no calibration needed. So in order to start any sort of recording, we basically go for any calibration. Calibration is nothing but setting your instrument to some specific count, such that whatever the readings we are taking will be in a correct form. So here for the Bluetooth we don't require any sort of calibration. Just we can, if you just switch on the Bluetooth, so it start capturing the travel time data or OND data, that is origin and destination matrices. Next, so the Bluetooth devices are more prevalent on broad vehicles and with portable electronic broadcasting. That is nothing but the amount of data collected over time become more accurate. So here we are able to calculate more accurate type of data and the valuable data for the travel time and estimation purposes. So the Bluetooth data, so here some detectors are there. If you see, can see the traffic poles. At the traffic pole some sort of detectors are there. So from where the vehicle is moving, from where it is like how much time it is taking to move from one pole to the another pole, we are able to collect the data. So likewise we can calculate the travel time and the origin and destination of the vehicles onto the road. So this is the Bluetooth detection. Next, coming to audio detection. So what is this audio detection? So it is basically possible to measure the traffic density on the road using the audio signals. So it is nothing but the cumulative sign which is coming from the tire noise, engine idling noise, honk and other turbulence noise. So this is something different where we are able to detect the audio of something, and then we are able to find out some parameters related to this, such that those parameters can be taken by the ITS for some smooth flow of traffic on the road. So basically in this audio detection we are able to take the tire noise data, engine noise data, engine idle noise data, honking of the vehicles, the air turbulence noise. So basically a roadside installed microphone picks up the audio that basically compares the vehicle noise and the audio signal processing. So here the audio signal processing technique take place in order to estimate what is a traffic state. So as like as the Bluetooth sensors, if we can place some sort of audio signals at over it, so that audio signals basically compares the different types of vehicle noise, and then the audio signal processing takes place, which is used to estimate the different traffic state. So this is how the things look like. Okay, so this is a siren where it is fed to the microphones, and then this is the traffic signals. So as like just if we can place a visual verification, so that some sort of noise is coming, it is being detected, and finally some sort of application is happening place where we are able to find out what is the traffic at that point. So next, moving to another subtopic of our unit 5, which is travel demand management. So basically the word itself is travel demand. So it uses a ITS tool like basically to influence when, where and how people travel in order to reduce the congestion and peak hour demand. So basically what is the demand of the travel or during the peak periods such that we can reduce the congestion, and basically when to travel, where to travel and how people travel, that we are going to see in this parameter, which is related to travel demand management. So basically the common ITS based TDM strategies includes the real-time traveler information. So this is the best example of the GPS which we are using, where we can get the real-time travel information. So sitting at one remote location, we are able to see what is the real-time traffic happening at that location. So that is a real-time traveler information. So where the traveler is now at this point, we can trace with the help of the latitude and longitude position, and we can find out what is the real-time traveler information. Dynamic route guidance. So this TDM gives a route guidance. Route guidance in the sense, suppose we are able to go from one point to the another point. So they can be very more routes are like they can be one or more routes. So which route to be taken, which route to be preferred, so that guidance also can be given by this travel demand management. Parking information system. So it can give the different parameters or different information related to parking system. Telecommunicating and flexible work hours support. Congestion pricing and intensives. So something related to congestion, something related to travel, the TDM is given. So this TDM basically improves the network performance with the need for additional physical infrastructure. So next, coming to information fusing from multiple traffic sensors modalities. So basically we are getting information from different sources, like we have seen in the previous slides, like we are getting information from intrusive, non-intrusive, Bluetooth, some audio and some different parameters related to this. So we are getting information from different sensing technologies. So basically what we can do is we can fuse all the information, that is called as fusion of information. So basically what happens over here is different sensing technologies, we are able to combine those all information in the intelligent way to determine the traffic state accurately. So here in the data fusion, what happens basically, it utilizes the roadside collected acoustics, image, sensor data, in the sense what we are getting data in form of acoustics, in the form of image, in the form of some sensor data or camera data, that we are able to combine to find out the advantages of different individual methods. So we are able to get different information from different sensing sources. So so basically in order to implement or in order to have a good real-time traffic data, we need to fuse all the information and then feed into the ITS such that there will be a smooth and proper flow of traffic onto the road. In the next coming slide, we are able to see different applications related to intelligent transport. So there are various applications. So let us see different applications one by one. So emergency vehicle notification system. So when we are getting data from different sources, we can go for the emergency vehicle notification system. What does it mean? It means that any sort of incident or accident or any breakdown has happened place in the mid-block section or an intersection, some emergency vehicle notification should be given to the nearby authorities, or suppose any accident have happened, some emergency notification or some sort of signal alert should be given to the nearby hospital such that the medical help will be in no time. So likewise, we can go different type of, we can feed different type of information into the notification system. And then the vehicle e-call is generated either manually by, so that like basically this sensor is giving what different types of information either manually or automatically or by activation if any sort of accident is there, such that it is reaching the nearby emergency point, and from that nearby emergency point, so the vehicle can communicate with the trained operators, and then the medical help or whatever the relief which is required at that period of time we can get. So that is nothing but the emergency vehicle notification system. So here the minimum set of data which information is, so what type of information is needed for this? So what is the incident, what is with what time, where is that location at which the incident have happened, what is the direction of the vehicle in which it was traveling, and what is the vehicle identification. So this is what is emergency vehicle notification system. So if any sort of incident or a breakdown or any accident have occurred on the road, okay, so some sort of information or vehicle notification system should be coming such that an emergency vehicle can reach its point within the no time. Next is automatic road enforcement. So let us see different type of road enforcement techniques. So first one is automatic speed enforcement gantry. So here automatic speed enforcement. So here we are able to regulate the speed of the vehicle on the road. So here what is happening is a traffic enforcement camera system will be there, which is consisting of a camera and a vehicle which is having a mounting device which is used to collect and identify the different vehicles which is disobeying a speed limit. So if the vehicle has jumped the speed of the vehicle and not obeying the speed limit, then automatic some sort of legal requirement will be taken place. It means what? Basically, if there is an any traffic speed, so in this traffic speed some particular speed is maintained, suppose 100 km per hour or 120 km per hour or some 80 km per hour or 50 km per hour. So that speed should be maintained. So if the vehicle is disobeying that type of speed, then automatically some sort of ticket or some sort of challan will be issued based on the number plate. So this traffic tickets are sent by a mail or by to the some sort of SMS to the vehicle user, such that saying that he have illegally had jumped the different type of speed over there, and he'll be playing the challan related to that. So for that the speed cameras are required, which is used to identify the vehicle which is traveling over that type of speed. So basically that devices uses radar to detect the vehicle speed or electromagnetic loops which is buried into the road. So this is nothing but the intrusive. Intrusive is nothing but some electromagnetic loops which is just there at the beneath of the surface of the road. Or the red light cameras that detect the vehicle that crosses a stop line at designated place with the red signal light is showing. So automatically some sort of sensors are detecting if the speed limit is reached. So basically if you see over here, the speed limit says at 40 km per hour and the speed at which the vehicle was traveling was 38 km per hour. So this is fine. So then when it is more than 40 and this shows in red in color, and based and some sort of cameras are detecting the number plate of this vehicle, and suppose if this crosses the speed limit, then an automatic challan will be generated and sent to the user of the vehicle. So that is automatic speed enforcement gantry. The next let us see, that is the bus lane camera, so that identify the vehicle traveling in the lane reserved for the buses. So here the bus lane cameras, so there are like in developed countries there are specific lanes for different type of vehicles. Like for cars we have different lanes, for the bus we have different types of lanes. So some lanes are basically reserved for the buses. So here the bus lanes can also be used by the taxis or vehicle engaged in carpooling. So in the carpooling, the bus lanes can also be used by the taxis or vehicles which are which nothing but these are the public related vehicles. So for the public transportation. So some different lanes has been there. So then level crossing cameras are also there, which identify the vehicle crossing the railway at the grade illegally. So at the railway crossing also there are some sort of cameras. So identify whether the people are moving though the gate is down at the crossing. So where if the people are crossing then illegally, then also some sort of information is being sent to the nearby authorities such that they are illegally moving over there, and some sort of action should be taken for them such that we can ensure a proper enforcement on the road. Like different parameters like double white line cameras are also there, which identify the vehicle which is crossing the lines. High occupancy vehicle lane cameras are there, which identify the vehicle violating the high operating vehicle requirement. Then some sort of cameras at the intersections are also there, where we can some turns like prohibited, so they are written as red. So this type of camera is mostly used in cities or in the urban heavy areas. So different road enforcement techniques are there such that we can detect if any illegal activities are happening on the road. So you can see different type of cameras has been installed on the road. So where it ensures it can be combined with the ITS system, so for the smooth flow of travel on the road. Next is variable speed limit. So in this speed limit, basically for different types of vehicles we have different types of speed that changes with the road congestion and other factors. So basically based on the road congestion we can change different types of speed on the road. So basically or typically this type of speed limit tend to decline due to the poor conditions rather than improved in the good ones. So the speed limit or it is coming into enforcement. So a particular road is having a particular speed limit. So we cannot maintain a high speed in the rural areas or urban areas where huge amount of traffic is there, and we cannot slow our vehicles in the expressways. So a speed limit is there for different type of road, and it has come into enforcement in 1995. So the initial results that indicated the journey time, the smoother flowing traffic, and the fall of accidents such that it was made permanent in 1997. So the initial results indicated saving in the journey time. So based on the type of the road, different speed is being designated. So that speed, so basically it indicated saving in the journey time. So if you are able to move at the high speed, we should maintain the high speed, different variable speed. So this is an example of different variable speed for different types of vehicles we can maintain on the road. So different lanes is being specified for that different type of vehicles. So we can maintain that type of variable speed. So it can we can go with the proper speed onto the lane. So likewise you have different types of variable speed associated with various different types of lanes. So in the next class we will be seeing regarding the collision or accident related systems.